Hi and welcome to Geeks for Geeks. Can I have a quick +1 in the chat if I'm visible as well as equally audible? Then we would just start after a few minutes. Let me just see if I'm visible as well as equally audible or not. Hi Satyabrat Ojha, how are you? By the way, I was waiting for your message. You're always the first one to reply. Okay, thanks a lot. Seems like. Okay. So we would just have a waiting window of just 1 minute. So let's just have a countdown of 1 minute. After 1 minute, we would just start itself. Okay. How many people turned up? Can I have a quick +1 in the chat if you have turned up? By the way, today we would be learning about heaps and graphs, but most of my focus would be on graphs, and if I get time I would be focusing on heaps, but as heaps is a little bit comparatively easier topic, so hi Chandu, how are you? So I would be kind of focusing more on the graph terminologies, then I would be focusing on finding the number of connected components, then BFS, then DFS. BFS is breadth first search, DFS is depth first search. Hi Abhirati, hi Mushkan Dhawan, how are you? Okay, so let's start itself. So first, see, we have a graph. Okay, so let us today learn about graph. So what is basically a graph? Okay, so in our daily life we have come across graph many number of times. Okay, like if you just observe a particular network, more preferably if you visualize the Facebook. Okay, if you visualize the Facebook, then there is a thing known as I am a friend to someone, so I am connected to that person. Fair enough, this is the first one. And so I would just write Facebook here. Okay, Facebook. Okay, so I'm connected to the other person, first one. Then there is a mutual friend kind of thing, for which please explain as beginner, please. Yeah, absolutely, you don't need to say me please. Okay, absolutely, I would start from the very beginning, from the introduction to definition, then the algorithms. It's absolutely fine. Okay, just let me know where I need to stop, where I need to explain more. Okay, just let me know. Okay, so you can visualize like there are different people, and they are connected to each other through links. And suppose I am a friend of my girlfriend. Suppose I have a relation with my mother, I have a relation with my sister. Okay, these all things. And there is a mutual friend of there is a mutual friend. Okay, that is there also. Okay, so now let us also talk a little bit about. Okay, just a sec. Seems like my pen tab is not working. Okay, seems like it started working. Okay, sorry about that. So suppose, so we now have visualized what is a graph. Now we would learn the differences between a tree and a graph too. But let us first understand. Suppose this is 1, 1 is connected to 2, 2 is connected to 4, and 2 is also connected with 5, and 2 is also connected with 1. Then 4 is connected to 5, then 4 is connected to 2, then 4 is connected to 1. We know that, and 4 is also connected with 3. So this thing, this which I'm highlighting, is known as nodes. Okay, and the path has a different meaning, but this one, the connection between them, the only thing, suppose there is only one edge and there is one edge, so the path between them, for now let's suppose it is a path, but path has a different meaning altogether here, and it is known as edge. Okay, this is known as node, this is known as path. But the known as also told as vertices. Vertices. Okay, the nodes are also told as. Now I have written all the topics, okay, that are needs to be told. Okay, so now this is nodes and this is vertices. Now let us talk a bit about path, because what is path and what is an edge. Now suppose there is two nodes and there is a this between them. So this can be told as the path from this to this. Suppose this is A and this is B. So this is a path from A to B and this is also edge from A to B. But suppose this is C and then this is B. So these two would be called as the path from A to B, but this would be called as an individual edge, this would be called as an individual edge. Why? I would tell you. So basically suppose करो कि तुम और तुम्हारी गर्लफ्रेंड का हाउस दो गली बाद है, दो गली. तो पहला गली जो गया वो एक एज है, वो गली एक एज है. ओके, दूसरा गली दूसरा एज है. बट तुम्हारे घर से उसके घर तक जो रास्ता है दैट इज नोन एज पाथ. ओके, नाउ सपोज आप और वो सेम गली में हो. ओके, सो दैट इज ऑल्सो अ गली एज वेल एज अ पाथ. ओके, so it can be both are absolutely the same. So learn the differences between these two. Okay, so just tell me if the difference between path and the edge is clear or not. Okay, this is of absolute importance. Now the next thing we have is length of a path. The length of a path is absolutely easy to understand, and then I would try to relate it with a real life scenario. Now suppose this is the path from 1 to 5 that is highlighted here itself. Now this is the first lane that we would be crossing, this is the second lane we would be crossing, and this is the third lane we would be crossing. So the length of the path is 3. Suppose आपकी और आपकी गर्लफ्रेंड का हाउस 3 गली के बाद है. So the first gully is your first length, first edge, then the second edge, then the third edge. So the number of edges that you encounter, okay, that you encounter in the whole path is your length of the path. Okay, fair one. Now suppose we have something like this. Okay, we have 1 and we have 2 and we have 3. Now suppose this is the edge that is there. Okay, fair enough. Was it vertex? Okay, thanks a lot. Okay, yeah, so let's just see. Now suppose from 1 I can reach to 2, from 1 to 2, from 1 to 2. What are the path that I need to find? So I need to go from 1 to 2, and what I can do is I can go from 1 to 3 to 2, and if the last node of them is matching, then we can say that a cycle exists. A cycle exists in the graph. Okay, but in trees there are no cycle. Okay, trees में cycle नहीं रहता है. Why and how I would tell you that, but for now just understand that there can be a cycle in a graph, but there can't be a cycle in tree itself. Just remember this. Okay, fair enough. Then we next have the connected. Okay, now suppose you can just take the example of this only. So I would just take the example of this. Let me just remove it. Okay, fair enough. Now suppose, am I late? Yeah, a little bit late. Okay, that's absolutely fine. Okay, so fair enough. Now suppose, what is a connected component? Now suppose from a particular node I can visit the other node, and I can visit all the other node. So from 1 to 2 I have a path. Yes, I do have a path. And to be honest, I have a path from everyone. So I have a path from 1 to 2, I have a path from 1 to 5, I have a path from 1 to 4, I have a path from 1 to 3. Then from 2 also I have a path from 3, 4 and 5. 1 is already verified. And I also have a path from 5 to 4, 5, 4 and 3 also. From 4 I can have a path from 3 and 3 from the same thing, same here itself. So we can visit each node from each, we can visit the other node from each node. ओके मतलब हम एक घर से किसी भी घर में जा सकते हैं. आपकी एक 5 गर्लफ्रेंड है, आप एक गर्लफ्रेंड के हाउस से किसी भी गर्लफ्रेंड के घर जा सकते हो. फेयर एनफ. ओके, so that is it. So if that is the condition, then we can say that it is a connected component. Okay, connected component. Connected component. Okay, by the way, we would be doing a question today, how to count the number of connected components. We would be doing this question, so please little bit look about that. Okay, and we would again explain you. Okay, now the next thing coming in is tree. Okay, what is basically a tree? I told everything, what is a tree and what is the difference between graph and tree. But graph और tree मुझे तो सेम लगता था in my initial days. So what is the basic difference between graph and tree? So a tree has n nodes. Okay, tree has n nodes and n minus 1 edges, and it is connected, and the next condition is no cycle. Quickly take a screenshot of this if you are too lazy, but if you want to remain active for the rest of the class, then you just need to write it down. Okay, so just take a screenshot or write it down quickly. Okay, by the way, 5 girlfriend is not feasible because at some point of time they would collide and they would kind of take a large explosion. Okay, so the next thing is that we have a directed and undirected. Now suppose I have a road. Okay, suppose this is Satyabrat's house and this is my house. Okay, so from my house to Satyabrat house, I can go from Satyabrat house to my house, and if he goes from his house to my house, he needs to live in my house. He can't go back to his house. Okay, there is only one way. Okay, we kind of tell ना कि यहाँ तो सिर्फ one way है, हम एक ही तरफ जा सकते हैं, we can't go back. Okay, so if that is the condition, we tell that it is a directed graph. Okay, if the opposite condition occurs, okay, vice versa kind of thing, then I can visit from Satyabrat's house to my house, and then he can also do the same back and fro, and I can also do the same back and fro. If this is the condition, then we need to tell that it is an undirected graph. By the way, the graphs are divided into two big branches, that is undirected graph and directed graph. And for directed graph, we have different algorithms to apply. And for undirected graph, we have different algorithms to apply. Okay, this is the basic difference, and we would learn about them. Okay, now the next thing we have is weighted and unweighted. Okay, now suppose I have a girlfriend 1, I have a girlfriend 2, and I have, this is my third girlfriend, and this is me, of course. Okay, now suppose what I can do is, from my house, if I visit this house, okay, if I visit, suppose I can take this route. Okay, just I can take this route. Okay, if I take this route, okay, and if I take this route, and if I take this one, okay, fair enough, the graph can be like this. Now it is told that if I go from, this is my house, if I go to the girlfriend third's house, this is costing me 2 rupees. Okay, this is costing me, Or let's take the example of a petrol. So suppose it is costing me 200 rupees, and from here it is costing me 300 rupees, and here it is just costing me 100 rupees. Okay, and from here to here it just cost me 50 rupees. Okay, and this cost me 10 rupees. He is just living next to my home. Okay, so now suppose, which is a better path? Which is a better path? To go from this direction or to go from this path? Which is better? If we take this path, the cost would be 300 plus 500. That 300 plus 200, that is 500, and this is 100. And 100 is more cheap, so I would try to opt this condition. And in this scenario also, if I want to visit my second girlfriend, I would take this path only because it is just costing me 10 rupees. And to be honest, you would be surprised to know that you just had an example of a weighted graph. Okay, this is an example of a weighted graph. Okay, and this is an example of a weighted graph. Okay, fair enough. Now the same thing, whatever we were discussing till now, we were not assigning any weight. Okay, अब तक तो कुछ weight तो था नहीं, अब तक तो कुछ पैसा लगता नहीं था. Okay, अब तक तो कुछ पैसा लगता नहीं था. So ये जो पैसा नहीं लगने का बात है, we call this as unweighted graph, and ये जो पैसा लग रहा था, we call this as weighted graph. Okay, now there is also a thing known as Indegree and Outdegree. You would be needing it for a little bit later, but why not learn it now? Okay, so what is basically a Indegree? A Indegree, to understand, is very easy, to be honest. Okay, just you need to concentrate on a little bit. Okay, so suppose I go from this to this. Okay, and this is suppose my friend 1. Okay, this is my friend 2, and this is me. Okay, now suppose I have like this. Okay, so I can tell the Indegree of me is what? The Indegree of me, okay, the Indegree, or what is Indegree? Indegree are the number of nodes coming towards me or getting me inside me. Okay, so the Indegree of this, Indegree, okay, Indegree of this would be 2. And suppose there are 2 Outdegree, suppose there are 3 Outdegree. So the number of Outdegree would be 3 itself. Okay, result minus 0 2 is a favorite. Sasti aisi liye. Okay, fair enough. Sid, tree versus graph, please. Yeah, why not? Absolutely, that's absolutely fine. Okay, let's just do the reverse of it and you would get to know. Tree has n nodes, but the graph might have n nodes. It can have more than n nodes, it can have less than n nodes, it can have equal to n nodes, and it might have n minus 1 edges, but it might not have a n minus 1 edges. It can be connected, it can't be connected, and it can have a cycle. Okay, so basically ट्री में जितने क्वालिटीज होते हैं वो ग्राफ में रह भी सकते हैं या नहीं भी रह सकते हैं. दे कैन बी in graph or they might not be in graph. Okay, so remember this. So every tree cannot be called a graph, but every graph, but every tree can be called a graph, but not every graph can be called a tree. Okay, now tell me if till this point this thing is clear to you or not, and let's have an upper bound to this waiting, that is of 1 minute. Okay, fair enough. Just quickly tell me if this thing is clear or not. Quickly tell me if this thing is clear or not. We have very less viewers as the portion we are moving forward. We are kind of losing the number of viewers. Okay, can you just please like the video if you think that I am doing a good enough job? Okay, so we have 15 minutes more. So quickly tell me if this thing is clear or not. Clear. Okay, fair enough. Thanks a lot. So let's now just move forward with this. Okay, Muskan Dhawan, thanks a lot, Lalit. So what about, okay, so what Satyabrat Oja is clear. What about Chandu? What about Chandu? Chandu, is this clear? Nirmal, is this thing clear to you? Just you two tell me. So we would just move forward while they tell us. Okay, fair enough. Now we have a thing known as representation of graphs. Graphs to पढ़ लिया, but how to represent it in terms of coding, we would understand it, but after we have learned how to traverse it, so that I would have an example. Okay, I would have a way to tell you, but let's just do it. Okay, suppose let's just have a graph and let's just represent it. Okay, fair enough. And this is what, okay, so let's just have a tree or something, graph or something. We copy this and we paste this here. By the way, if anyone wants the note of this, I would be replacing my exchanging my laptop. Okay, so just let me know before I exchange my laptop. I would be exchanging in early February. So if you want the PDFs of these all things, just mail me or just respond me in Telegram. I would be more than happy to tell you. Okay, fair enough. Now we have two representations of graphs. Okay, representation. We have two representation of graphs. First one is the adjacency list representation. Adjacency list representation. The next one is that we have a adjacency matrix representation. Okay, we have this. Now let us first understand what is adjacency list representation. Adjacency list representation is absolutely easy to understand. So if you have 1, if you have 2, if you have 3, if you have 4, and if you have 5, basically the number of nodes. So if you have a path from 1 to 3, so I would insert from 1 I can travel to 3. Okay, from 1 I can travel to 3. Okay, and this is an undirected graph, and I told that in undirected graph I can move to and fro, to and fro, to and fro. Okay, so from 3 also I can visit that, but we would see to it. Okay, when we would go to 3. So from 1 I can visit to 3, from 1 I can visit to 4. So we would just say yes, 3 can be visited as well as 4 can also be visited. Then we have this 2, so I tell that yes, 2 can also be visited. Okay, then we come to 2. From 2 I can visit 1, 4 and 5. So 1 and 4 and 5. Let's just change the color. Now suppose we have 3. From 3 I can move towards 1, I can move towards 4. So from 3 I can move towards 1 and 4. From 4 I can move towards 1, 3 and 5. 1, 3 and 5. I can move towards them. Okay, so 1, 3 and 5 itself. Thanks a lot Chandu. Bro, आपका टेलीग्राम चैनल कौन सा है? Just text me on LinkedIn. I would provide you the telegram channel link. Okay, so now from 5 I can visit to 2, I can visit to 4, I can visit to this 2, I can visit to this 4. These are the two parts I can visit directly. So I would just write 2 and 4, and this is the adjacency list representation. Okay, this is the adjacency list representation of a particular graph. Okay, now we would understand the adjacency matrix representation of a particular graph. To understand that, let us first make a matrix. Okay, of this much. Yeah, this much is okay. Let me just check if I'm not blocking the view. Yeah, I'm not blocking the view. This would be for 1, this would be for 2, this would be for 3, this would be for 4, and this would be for 5. and this is for 1, this is for 2, this is for 3, this is for 4, and this is for 5. Now, as we think that adjacency matrix would be involving a matrix, yeah, Lalit, I received your message. I would be texting you back when I finish with this stream. Now, from 1, the first one would be the 1, then 2, then 3, then 4, and then 5. And from here, I have 1, 2, 3, 4, and 5. Okay. So now from 1, so let's just start filling this up. So from 1, I can visit to 3. So 1 and 3. So I would just write here 1. From 1 to 4. So I would just write here 1. Okay. From 1 to 2, I would just write here 1. From 2, I can visit to 1. I can visit to 4. I can visit to 5. From 3, I can visit to 1. I can visit to 4. From 4, I can visit to 1, 3, and 5. From 5, I can visit to 2 and I can visit to 4. And rest all the numbers would be 0. Okay. Rest all the other numbers would be 0. Okay. So, I can say that from this is the adjacency matrix representation of this one. Okay. So by the way, what are the differences between them? So for this, a vector of arrays is required for the adjacency list representation, or for this adjacency matrix is required of n cross n. Okay. So as the name suggests, we would now be differentiating between this, and we would be talking about the pros and cons of both. Okay. So what are the pros and cons of both? So here we would be writing here list, and here we would be writing matrix. Okay. And we would be having a line between them. So in the adjacency list representation, suppose I just want to quickly check. Suppose Mushkan Dhawan came to me and asked me if there is an edge from 1 to 5 or not. So what I would do is, in the adjacency list, I would go towards 5 and I would start searching 1. Okay, I would start searching 1. But if I go to 5 and I directly go to 5 and 1, there is no. So I can quickly say that it is 0. So in this, the searching for a particular edge, the connection between them is order of 1 for adjacency matrix, but order of n, or the linear time complexity, for adjacency list. So connection, okay, for connection for matrix it is order of 1, for list it is order of n. Okay, so you can visualize this as, suppose there is a very popular guy in your college or your high school, and then suppose you ask him that how many girlfriends you have. Suppose he has a large number of girlfriends and he needs to iterate over all his girlfriends. So in the case of matrix, suppose I directly go to 5 and 1, and if it is 1, then I would be returning that yes, there is a connection between 5 and 1. But if it is 0, then I directly tell that yes, there is not a connection from 5 to 1. Okay, fair enough. This is what I can say. Now the next thing. Now for the adjacency matrix, the space that is required would always be n cross m, number of nodes into number of nodes. For this, it would be n plus m, the number of nodes plus the number of edges. Okay, the number of edges is so 2m. Why? Because for each edge, if it is an undirected link, we go from this to this. So Chandu Rhythm, you want the Telegram link, just go to the LinkedIn. Just go to LinkedIn, search Siddharth Hazra. I would be just texting you a dot and just type up this name. You would be seeing my pic, hopefully. I'm not that much famous, to be honest. I'm just a regular coder. Not a regular coder, just a regular guy doing his job. And you would find me and you can just send me a request. Fair enough. So this is the basic difference, but in terms of both, it is seen that sometimes this is good, sometimes this is good. In the same way, you would require both of these, okay? You would be requiring matrix as well as list, adjacency list representation. But to be honest, you would be requiring this, okay, for 95% of your graph problems, and you would be requiring this for 5% of your graph problems, mostly for Floyd-Warshall, okay, Floyd-Warshall, okay, Floyd-Warshall, and for the other, we would be following a pattern of doing list adjacency list representation. Why? Because it is space optimized. What about index matrix? Index matrix is kind of out of the scope of this syllabus. So whenever you try to learn for competitive program, why do we always prefer that you can do competitive programming, then you can say do DSA? Why? Because competitive programming kind of provides you with a roadmap. Okay, suppose you are not able to do a particular problem, so you know that I need to prepare a lot on this topic. So you have a particular roadmap. It gives you a proper direction. But when you talk about these all things, so if you talk about DSA or stuffs, there is also known as Prim's algorithms as well as the other algorithm. So Prim's algorithm and Kruskal's algorithm. You can solve all the problems using Kruskal's algorithm. And to be honest, in my coding journey, I never found a problem which is specifically for can be solved only using Prim's algorithm. Okay, so this is the thing, you need to kind of segregate, okay, what is important and what is not. You need to find options, okay, the easy options you need to pick them up. Fair enough. So let's just have a list representation. Okay, suppose I just want to build a graph of this. Okay, I want to build a graph of 1, then 4, then suppose from 1 I can have an edge from 2, and this is from 3 to 4. I can have this, okay, not 3, rather we need to have 5 here. Okay, so we can have an edge from 1 to 4, then 1 to 2, and then from 3 to 5. So we are told that the input would be kind of like this. Okay, so you would be told the input like this. So first would be the number of edges, number of nodes, and then you would be given the number of edges, and then you would be given the relationships that you would be given u and v, and this means that you have an edge from u to v, and it would be told, or you need to tell by yourself, that if it is a directed or undirected. Okay, the number of nodes can be represented as n, and number of edges can be represented as m. So in this scenario, we have the number of nodes as 5, the number of edges as 3, okay, and we have edge from 1 to 4. Okay, we would just write it directly. Why to waste time here? Okay, so what can be done is, let's just start the coding part of this. Okay. Okay, now just let me load the sample one. Yeah, so we would take the input n, then we would do the c in n, then what we would do is vector of int of g of n. Okay, g of n, or what we can g of n, or here we would write g of small n. Okay, and then what we are given the n, int m and c in m, and then what we can do is we would have m number of edges u and v. So we would be just going from I is equals to 0, I is less than m, and I plus plus. Then I would be initializing int u and v. Then I would be doing c in u and c in v, and g of u dot push back v, and g of v dot push back u. This is, I can do it. Okay, I can do it. Now we need to move. Lalit, thanks a lot, it means a lot. Okay, so this is how we can build up the adjacency list. Okay, so let's just run this and see this. Okay, we would just stop it, and the number of nodes was 5 and the number of edges was 3, and we have a edge from 1 to 4, 1 to 4 and 1 to 2. So we would just write 1 and 2, 1 and 4, and then we have a edge from 3 to 5. Okay, so from 3 and we have a 5. Okay, so we would just save it and we won't be able to see the effect, but that is done itself. Okay, that is absolutely done. And we would be now learning a little bit about DFS, and then we would be moving forward and we would be seeing the effect of what we are doing basically. Now I would be just writing here const int capital of N. Why? Because I am more accustomed to this, and let's just say that we have 10 number of nodes, and okay, and then I would just declare this as a global variable. Why global variable? So that कहीं भी कोई भी function से हम इसे access कर पाए. That is why initially I was writing it with capital of 10 and capital N. So we would be using this for the rest of the class, so make sure you understand this very carefully. Now we have took a lot of things. Quickly tell me that if these things are clear to you or not. We again have a countdown or a break for 1 minute. Quickly tell me if all these things are clear to you or not. Chandu, Lalit, Dipti and Satyabrat and Abhigal, Muskan, okay, then Nirmal, okay, and then Abhirathi. Can you please can you all tell me that if this thing is clear or not? Okay, so we have the 1 minute. Okay, so now let's just move forward. Thanks a lot, Chaldi Chilla Gundla. Okay, thanks a lot. Okay, so now we would be learning about a traversal. Why? Because suppose there is a graph that is given, and suppose there is a road that is given. So what is the basic use of that road? The basic use of that road is to travel from that road. So we would be now learning about a traversal technique, that is DFS, okay, which is depth first search. Depth first search, okay, which is known as this thing, depth first search. Now for the rest of the stream we would be referring this as DFS. Okay, now what is DFS and how this works is that I told you in my initial classes that you need to go through recursion to understand graphs, and this is the time when recursion comes into play. So this is a recursive approach. Okay, recursive approach. So whenever I talk about recursive approach, I always tie about dry run, recursion tree, these all things. Now suppose we have an initial graph like this. Okay, so we have a node like this, we have a node 2 here, then 3 here, then suppose this is 4. So we have an edge from this and this, and suppose this is the edge and this is the edge and this is the edge. We have a graph like this. Okay, so let's not add the edges at these all positions, let's just add it at this position, or let's just have a tree itself. Okay, let's just have a tree kind of thing, because for this we just need a tree kind of thing. Yeah, fair enough. So in tree we had a root situated, okay, but in graph we can't have a root or something, okay. So what is the most common way is that the most common and the most basic way is that we start from the first node itself according to the question. If the question is not bounding us to start from any particular node, we don't do that. But if it is not telling us, then we start from the first node itself. If it is not visited, we start a DFS. But before that, we have a visited array, okay. Why visited array? Because it might be the case that it might have cycles and we might keep visiting, keep going, keep going, keep going, keep going. We can have this thing, okay. So this is 1, this is 2, this is 3, this is 4 and this is 5. So as we keep visiting, we would be cutting this off. So we would come to 1. 1 is not visited, okay. So first we would visit it, okay. So 1 is now visited. Now we would move to the neighbors of 1. Neighbors of 1 is 2 and 3. So if 2 is not visited, we would then start visiting it, okay. So we would start visiting it, okay. Now we would go to the next neighbor. It is not visited, we would visit it, okay. And then if the neighbors of this is also not visited, we would visit it first, and then we would visit the left child of it or the next neighbor of it. This is what we do. Now let's talk a little bit about the code of it, okay, because recursion is all about understanding the code. So let's just make it this side, okay. This is the visited array, okay. So now we would have, so we are kind of traversing, okay. So basically when we do a solo traveling, we don't want anyone else to know about this, okay. So in this scenario, what we do is we don't provide any feedback. So the return type of this type of solo ride is void, and let's just name it as DFS because that is what we are talking about. Then we have the source node. Every time a node is unvisited, we pass this as the source node itself, okay. Then we have the visited array. So first we would mark this as visited. So visited of source would be marked as 1. Then to traverse on all the neighbors of 1, we have this. So we have an array kind of thing. So for 1 we have 3, 4, 2. We want to traverse on all these elements. So we can simply use a for each loop. So I can simply say that for auto E, and I would name it as G of S, okay. So just see it. So if I just go to 1, G of 1 would be this, and I would start visiting these all nodes, okay. This is why I would writing G of E, okay. If visited of E is equal to 0, that it is not visited, then DFS of E, okay, and this is just getting closed, okay, and this is how it ends, okay. So basically क्या कर रहे हैं, जो unvisited है उस पे जाके visit कर रहा हूँ. अब जब तक उसका सारा neighbors visit ना हो जाए हम उसको visit करते, वो ही हमारा node रहेगा. तो इसके neighbors पे गया, इसके neighbors के इसके neighbors visited नहीं है, तब उसके neighbors के पास जाओ, and we would keep doing that till for a particular node all its neighbors are visited or not. तो एक चीज ध्यान में रखना, this is to be kept in mind, that you need to visit all the children of a particular node before that iteration is complete, okay. So vectors in Python is okay, one, but in vector sort we don't take a key and sort of value. Okay, you are talking about the C++ as well as vector Python. So I'm not taking part in this because I'm not much proficient in this. So tell me if this thing is clear or not. This visited array, this recursive application, and this code, and then this DFS. Take a screenshot of this. I would be giving you a question and then we would be solving this. Okay, so quickly tell me if this thing is clear or not. I won't have a time bound. I am ready to wait. Just tell me if this thing is clear or not. Okay, and then we would, if you want, I can do a dry run too. Okay, by the way, this 1 hour time frame is absolutely very less, to be honest. Okay, so to be honest, I want this time frame to be increased. Why? Because we have a lot of things to discuss. We have a Kushkal's algorithm, we have shortest path algorithm, we have then 0 1 BFS, we have BFS. So I was thinking that I should discuss BFS too, but this is already 45 minutes 58 seconds. Okay, so it's a little bit difficult to fit in this and I don't want to hurry over this. Okay, थोड़ा ही पढ़ के जाओ, but I want you to learn it very good. Okay, so that's great. The things are now clear. So let's take a question. Okay. So by the way, do we have a magnifier or something? Just let me see if we have this zoom more tools. Okay, I would try to search if there is a magnifier or something or not. Okay, so just give it a read. Okay, so what is the question? The question is telling us that we are given a connected undirected graph and we need to perform a depth first search of the graph and use the recursive approach that is just given, and this is 0 indexed. This is not 1 index, so you don't need to have a problem. So this is 0 1 2 3 and 4. So let's just take a screenshot and I would give you the dry run, and I hope that you would be able to solve this. Okay, so start solving this. Okay, just search for DFS of a particular graph and you would be getting DFS of a graph, and then you go to GFG, just write GFG and you would be getting this link. For auto D, take a reference. Yeah, I would be telling you. Okay, so let's just see. Okay, so let's just have this. Okay, now for the graph would be like this. 0 would be having 1 2 4, then 1 won't be having anything, 2 won't be having anything, so 1 won't be having anything, 2 won't be having anything. For 3 it would have 4, and from 1 I can move to 0, from 2 I can move to 0. This is very easy. And from 4 I can move to 0, I can move to 3. These are the two things that I can move to. Okay, now suppose I went to, suppose whatever we are visiting, we would just mark it. Okay, so this is the first node 0 and we have not visited it. So what we would do is we would just go to 0, mark it visited, then we would go to the neighbors of g of 0. G of 0 is this. So g of 0 is this. 1 is visited. No, 1 is not visited. So we would start the DFS from 1. So g of 1. Now 1 would get visited. Now the neighbors of 1 are 0, but it is already visited, so we won't do that. And there are no more neighbors, so we would kind of revert back. Okay, now we have 0. So the next neighbor is 2, which is unvisited. 2 is unvisited. So we would go to 2, visit it, then 0 is already visited, we won't do anything. Then we go to 4. 4 is unvisited, so we would go to 4. Okay, mark it visited. 0 is already visited. Then we come to 3. 3 is not visited, we would visit it. Okay, then the neighbors of 3 are visited or not. Neighbors of 3 is also visited. So this is how we would visit each node, and we would insert them in the vector and we would return them. So just whenever you are visiting this node, just insert it in the vector. This is what you need to do. Okay, just quickly read and understand the statement. So when you are done with this question, quickly let me know that yes, Siddharth, I have read this question, and you can just start solving this question because we have a little bit time constraint. Okay, so we can have something like this. Yeah, so I would just rename it. Okay, I would rename it to G, and the number of, okay, why is this happening? This is because of this. Okay, yeah, this is because of this. Okay, oh sorry. Okay, I don't know why is this thing. Okay, just let us increase it so much. Okay, I'm absolutely very irritated by this. So let's just code in the editor itself. Okay, so you just have a simple thing and we would just paste it. Okay, and we have something like this. Okay, DFS of graph is this, and we have a node like this. We would just name it as N, and this is renamed it to G. You can use a stack 2 for DFS, yes, but the thing is that we are told that we need to use a recursive approach, and the stack is an iterative approach. And the next thing is that if you just want to use stack with recursion in the first hand itself, it would be a little difficult to understand. But when you are learning about topological sorting, you can always take a step to understand the stack implementation too. Okay, so can we start with the implementation? Can I have a quick reply from you all? Can we start with the implementation of this or not? Quickly let me know. Stack will use and DP takes, but the stack solution is more intuitive than DP. DP confuses. This is not a DP. Yeah, recursion also uses stack. Okay, let's just start with this. Can we start with this? Can you just quickly tell me? But recursion is not considered to use space. Why? Because it uses the call stack. Okay, so you can't directly say that yes, recursion can be termed as big of 1. Okay, so let's start with the implementation. So what we can do is the number of nodes is n. Okay, so we want a vector of int, and we would name it as visited of size n with everything as 0 initially. Fair enough. Then what we need to do is we need to have a vector of int. Okay, vector of int, and we would name it as, suppose, v itself. Okay, and then we would visit it. Okay, so we would have void dfs, then we would have the source, then we would have the visited array. Okay, vector of int of and visited, because we want it to modify this, and we also want this g. Okay, so we want to also need to pass this g itself, and then we also need to have this vector of int of v to store the answer itself. Now when we first reach at the first hand itself, we first mark it visited, so we would say visited of this s is equals to true. Visited of 1 would be made as true. Then we would just go to for auto of e g of this S itself. Okay, so if not visited of this E is true, that is this neighbor is not visited, then what we would do is DFS of this E itself, the visited array would remain the same, the G array would remain the same, and the V would remain the same. But after just visiting, what we can do is visited dot push back, and then we can just say that insert this S itself, and after all this is done, we can just call it. Okay, we can just call for the DFS. So we would start our loop in I is equals to 0, I is less than n, and I plus plus, and if not visited of I is true, then what we can do is DFS of I, and then we can have visited, then we can have this vector G array, and then we can have this V itself. Okay, and then after all this is done, we would return the V itself, because that is already getting edited by us itself. Okay, so we would just run it and we would just see to it, and then we would see that if I'm making any errors or not. So we would just compile and run. What is the output difference we would observe? So 0 1 2 4 3 0 1 2 4 3. So we are doing the pushback, but we are not getting this. Why this is happening? We are doing vector of E. So if it is already visited, we won't visit that. But if it is not visited, we do that. And then we start with the visited node of 0. If it is not visited, we visit it, and then this is also it. Okay, and we are passing it with the n itself, and then we are returning the vector void of DFS. So first we would mark this. Okay, this is the line of this is this, then this is this. Visited of S is equal to 1 visited dot pushback. Okay, this shouldn't be visited dot pushback, this should be V dot pushback. We are not pushing back in the answer itself. This is why we were getting this error. Okay, sorry about that. मतलब आंसर में स्टोरी नहीं कर रहे थे, that is what we were doing the mistake itself. So we have the expected output, so let's just see if we are getting the correct output or not. Yeah, we have solved. We said, bro, this conversation is, how can we teach you? It's our internet. So Sid, bro, this conversation is not suggestion for you, bro. Not suggestion for me, or it is not for me. You want to teach me, or you were just talking between yourself? Okay. So by the way, I would be more than happy to get taught by you. Okay, so just this. So we are visiting this particular node, and then we are pushing the source itself. Then we are pushing the unvisited nodes, and we are visiting it, and then we are marking the first we are marking everything as not visited, and then if it is not visited, we are pushing that. So this took us 59 minutes 5 seconds to complete, with all those terminologies, with the representation of graphs. So we learned so what all things we learned about. We learned about, so let's just see what all we learned about. Okay, so we learned about nodes, we learned about edges, we learned about path, we learned about length of a path, we learned about cycle, we learned about connected components, we learned about tree, we learned about directed, we learned about weighted and unweighted graph, we learned about in-degree or out-degree, and then we learned the difference between tree and a graph. Then we learned about what is a cycle, then we learned about representation, and mainly we have two types of representation, that is the adjacency list representation and the okay, thanks a lot Sandeep, it's absolutely fine. And we have two types of representation, that is adjacency list and adjacency matrix representation. Then we talked about what is the pros and cons of both of them, and then we have learned about depth first search, which is recursive, which is a recursive approach, and this is the code of this is how we are visiting it, okay, with proper dry run, and then we implemented it live and we got a AC. If I had more time, and I would try to accommodate one more session towards it, but I don't know if you want it or not. But as the view count is absolutely very going down, but still we have a lot of people who are interested and who are very serious, okay. So if you want, just drop me in the feedback form. I would be doing my take accordingly. So that's it for today. In the next, what you can do is, after this you can learn about how to count the number of connected components in a graph. Then you can learn about BFS in a graph, and then you can learn about how BFS produces a shortest path thing, and then you can learn about 0-1 BFS. Then you can do some random practice over graphs, and then you can go over Kruskal's algorithms, and then you can move forward with flawed version and 0-1 BFS, these all things. Okay, then I've done DSU, MST, and these all things would be taught by me. You don't need to worry about this. Okay, so that's it for today. Thank you and have a nice day. If you still have any queries that needs to be asked, I would again wait for the last 1 minute and I would see to it if you have any queries or not. So I would just make it 1.5 minutes and then start with the session. So quickly let me know. Okay, it's absolutely fine, Lalit. I was just asking because you told that this is suggestion. I told that you are suggesting. I thought that you are suggesting me something. So quickly tell me if you have any doubts or not. Else I would just take some rest and then I would sleep. Most welcome, Kiran. Good night, everyone. How to count the cycles in a graph. So basically what you can do is, first thing you should learn about how to detect cycle in a graph. Okay, first thing. Then the second thing you can learn about DSU. Then you can learn about path comparison, and then you should move forward to how to detect a cycle in DSU, and then you can count the number of cycles in a graph. Then you can go for this. Thanks a lot, Chalagunda Akash. Thanks a lot. It's absolutely fine. By the way, this green is not getting vanished, no? But my green screen is getting all vanished. Okay. Feedback done, bro. Thanks a lot, Lalit. Good night, Lalit. Okay, so that's it for today. Thank you and have a nice day. Good night, everyone. Thank you for running the session.